Okay, so everything we've done so far has been at standard conditions when the concentrations are all 1 molar, but what if they're not? So we can look at what happens when the concentrations are not 1 molar. And there are 2 ways we can do it. Sometimes you can just use Le Chatelier's principle and just look at how the concentration change shifts the equilibrium. And sometimes you need to actually solve an equation. That'll be on the next page. So the first thing we need is we need the complete balanced reaction. So we have to look at these. This one will stay reduction. This one will become oxidation, so it will reverse. So we will have silver going to silver ion and an electron. We're going to have to multiply this by 2. So that our electrons cancel. So our complete reaction is 2 silver plus H2O2 plus 2H plus into 2He plus and 2H2O. Okay, this is an equilibrium, so the fact that this is solid, this is aqueous, this is aqueous, this is aqueous, and this is a liquid are going to be important. Okay? So, this one stays at 1 molar, so that stays standard. This one goes to 2 molar. This goes to 2 molar. So we increased concentration of reactants. So equilibrium will shift to the right, which means it drives the forward reaction. Okay? So we could build a cell with different concentrations to produce small voltages. Now, Le Chatelier's principle, this will only predict the shift. It won't calculate the new voltage. In order to calculate the new voltage, we need the Nernst equation. Okay? Now, in the Nernst equation, notice we have E naught, which is what we've been using up until now with our standard conditions that we get from the chart. And then the E without the naught is at these new non-standard conditions. Okay? N is the number of moles of electrons. And then Q is the reaction quotient, which we saw in the equilibrium chapter. And remember, Q is like K, except K is at equilibrium, and Q is initial. But it's set up the exact same way. So, let's find the new voltage for this system. So, this one will stay reduction. This one will switch to oxidation. So we have 1 volt plus 0.76, so we have 1.76 volts for our E naught. This one's the one that's going to reverse. So zinc going to zinc 2 plus 2 electrons. So we need to multiply this by 2 in order to equalize our electrons. So our overall equation is this. Okay. Our ions will be aqueous. Zinc is a solid. Water is a pure liquid. Okay. And we need this because what is Q? Q is just like K. Products on the top. Coefficient becomes exponent. Reactants on the bottom. Coefficients become exponents. Okay? So our Nernst equation, E equals E naught minus 0.0591 over N times the log of Q. So we have 1.76 volts minus 0.0591 over, it was 2 moles of electrons, times the log of our concentration of VO2 plus is 1 times 10 to the minus 2, and this gets squared. Our concentration of zinc is 1 times 10 to the minus 1. Our concentration of VO2 plus 1 is 2, and that gets squared. Our concentration of H plus is 0.5, and that is raised to the 4th power. Okay, let me bring this over here so that we can see this and the calculator side by side, because we got a lot of stuff to simplify here. Okay, so 1 times 10 to the minus 2, and should have put that in parentheses, need to square that, okay, and multiply it by 1 times 10 to the minus 1. Alright, now I need to divide that by 4, because that's 2 squared. I also need to divide that by, put this in parentheses just to be safe, 0.5 raised to the 4th power. Bring down from my parentheses. Okay, so I am going to be taking the log of 4 times 10 to the minus 5th. Okay, so log of second function answer. Okay, so now I multiply that by 0.0591 divided by 2. So I have 1.76 volts minus negative 0.129. So I have 1.76 minus this answer, and so I have my E is 1.89 volts. Okay, so let's see if we could have predicted this using Le Chatelier's principle. Okay, this one is higher than standard. which would shift us to the right. This one is higher than standard, which would shift us to the right. This one is lower than standard, which would shift us to the right because that would be like removing something. And zinc is also lower than standard, which would shift us to the right. So yes, we would indeed be expecting a higher voltage.